So we're here with Javier from Cisco to talk about AI, Agentic AI, and the impact on traffic and network traffic. Great to see you, Javier.
Thank you. Thanks for having me.
Fantastic booth with all this AI infrastructure surrounding us.
Exactly.
I guess many of the service providers, really anyone who runs a large, wide area network, enterprise and similar, they're all very interested in how AI is enabling next generation applications.
Exactly.
But then, of course, what's the impact on the network? Tell us a little bit how you're thinking of that at Cisco.
Yeah, exactly. We started getting these kind of questions, maybe a year ago or so. They were trying to figure out how AI, as it gets deployed, was going to impact their networks. But most of the time, the discussion ended up being about data center, right? But we were trying to figure out, hey, what is the impact on the transport network, right? And in order to identify, first of all, what is the impact on the transport network, we wanted even, starting to answer the question, how is AI traffic different from the normal traffic? So this kind of led to all the research that we've been doing.
Yeah, and I guess one of the big questions, if we can put it in this way, is how is it different? Like, is it particularly most network service providers are used to serving human users, like web traffic, video streams, that kind of thing, some enterprise applications. In characteristic, can you see a difference in AI applications?
Yeah, we have identified some differences in the behavior. This is still an ongoing work, so we are going to continue doing more research, but we have identified difference, for example, in the traffic symmetry. The AI inference flows are more upstream heavy than downstream compared to web transactions. We have also seen differences in flow length and flow rate, which is a sort of indicator of how AI traffic is actually generated, and it's kind of makes sense based on the different characteristics.
On the other hand, new applications popping up, emerging all the time. Agentic frameworks getting more and more complex combinations.
Yes.
How do you deal and plan and work with that?
One of the things we've done is to, first of all, try to qualify with a single agent, for example, how it behaves. When we request an agent a specific task, what is the difference in terms of the network impact as compared if that task was done by a human? So we've seen, for example, that when we do the comparative analysis, traffic grows 450%, right? So the agent behaves as a traffic multiplier. Agents use network resources and cloud resources very, let's say, liberally, right? They don't constrain the amount of resources that they will use. And when you look at how enterprise might end up adopting this technology for more and more use cases, you can start to project what is going to be the impact on the network. Well, if every single agent drives a 450% traffic growth for that task, well, think of this at a scale, right? The impact on the network in terms of traffic growth might actually be quite significant.
Yeah, and the other thing I wanted to ask you about, we've seen a lot, and I'm an analyst, I see a lot of presentations, a lot of companies are we kind of understand a little bit the agentic model and somewhat how they work, and so we take that and then we kind of project. We go, well, with this as a principle, this is what's going to happen or might happen.
Exactly.
Fine. What I want to know, though, obviously we can all do that, we could be right, we could be wrong. What can we actually observe through experimentation, pilots?
Yeah, so maybe the first step is maybe what we've been doing, which is try to characterize at an individual level an agent, how it behaves. But then we can start exploring how, when you have multiple agents collaborating with each other, what does it mean? There is effectively a multiplying effect driven by agents. In some way, when humans drive a certain activity with the network, right, that activity happens at human speed, right? Whereas now with agents, whether you have an agent or many agents working together, that activity happens at agent speed, at software speed. So that pattern is only going to grow as Agentic gets deployed and gets adopted.
Other big aspect of this, I suppose, is where do agents live? Like, are they living on a device? Are they living in the cloud? Are they living here, there? The implications of that are kind of, it's a compound problem, isn't it, when you've got people coming in from everywhere?
Exactly, and the impact on the network is going to be different. I think we still need to see over time, what is going to be the distribution of this? There's going to be agents definitely running on the end user devices, probably in the phone, maybe in your laptop. There's going to be agents that actually run in a private data center or that run in a public cloud. We are going to see all that spectrum. And not only that, we're also going to see that the LLMs that power those agents are also located in different places. Some might actually even be running inside the phone and inside your device, but there will be others in the cloud that are the most powerful reasoning agents or reasoning LLMs. So when we see all these kind of different combinations, all of them are going to generate different traffic patterns. What percentage is going to be each, we don't know. And that's part of the ongoing work that we need to continue monitoring, how the deployment of agentic AI goes to effectively be able to map the traffic impact on the different network domains.
Yeah, the other thing I hear about is with this agent placement, if I can put it in those terms, is, well, we don't really know, but we start hearing this term like an AI fabric or an AI mesh emerging.
Yes.
Is that a term that you work with and you would kind of use it at Cisco or in your own work?
Yeah, exactly, because, at the end of the day, there is this like very strong and critical connection between where the agent runs and where inference happens. And inference might happen in different places. It could happen very centralized in some remote cloud, but it might also need to happen closer to the agent or to the end user, depending on where the agent is running. So what we are going to see is this inference mesh or inference grid that will need to connect agents with their corresponding LLMs for inference. So we are going to see those architectures emerging and probably seeing more and more how the inference happens more distributedly towards the edge.
So I know you've been quite deep in this. If you were to go and advise or comment to some service providers, people running big enterprise networks, as what could be their next step? What are some sort of actions they can take to get underway?
Yeah, I would say the first thing, given that AI inference is critical for the agents and for applications, the first thing is to have a good understanding of how AI inference is working in their infrastructure. So go and measure it. There are different technologies, different ways by which inference-specific KPIs can be monitored to really have a sense of, how is really AI inference flowing across my infrastructure. And then, of course, as AI inference evolves, driven by agentic AI or maybe other applications like physical AI, etc., right? And how that leads or drives additional traffic growth, they will need to start evaluating what design changes do they need to explore, what capacity growth do they need to add to their infrastructure as these technologies get more broadly adopted by their users.
Javier, one of the things I'm hearing about is token generation, how that helps run the different AI apps of physical AI right through into agentic in the cyber domain. Tell us a bit how you profile that traffic and what the impact is of token generation to the network.
Yeah, exactly. So, we've seen when we try to characterize how AI inference flows behave, especially as compared with transactions, with normal web transactions. And we have observed that AI flows tend to be longer in duration and they have a lower rate. And when you start exploring, hey, why is this happening? Why there is such a, let's say, significant difference, a statistical difference, it kind of aligns with the way, the generative AI content is generated, right? What you have in the backend is an LLM, it's a machine learning model that is generating the content like one token at a time. Mm-hmm. And that sort of naturally smooths the traffic, right, that is going to result on the network. Whereas if you compare it with a normal web transaction where you are downloading an image or some content from a web server, it will send it as fast as possible from the hard disk or from wherever it is fetching it from. But on the other hand, an LLM generates it, progressively. Whether
you
it's
can see
text,
that, can't you, when it's...
And that impacts the way traffic goes on the network. It goes more slowly on a per flow basis, but it's a longer flows. So this might impact the way we eventually, of course, if it consolidates and evolves and grows in that way, the way we plan, QoS configuration, queue length, etc., or even flow-based systems that might need to keep state for all those flows. If those flows stay for longer on the network, you need to keep a larger tables, larger state, which is aligned with having more distributed, for example, flow state systems like our Cisco Hypershield. Yeah,
certainly potentially a big impact, so something to really observe closely and go from there. Javier, thanks very much.
Thank you.